So I hope everyone is re-energized after the short coffee break. And I would like to introduce our first startup talk. And it's Signe and Troels from Race for Oceans Technology. And they're going to talk to us a little bit about making microplastic in our coastlines. So
thank you. Yeah, thank you so much for the invitation. My name is Signe, and I'm the founder and CEO of Race for Oceans Technology. And for the next 30 minutes, we'll stay above the surface. So one of the questions I have asked myself since 2019 is how can we collect the plastic on land that we cannot collect by hand? And this is the challenge, and this is the news headline from the World Economic Forum. So microplastic may disrupt the brain function. Then we have microplastic affect the body ability to fight infection. And we have microplastic enter the food chain. And the newest one, microplastic reduces photosynthesis in plants. So these are the news headlines from April this year. And by that knowledge and what we have seen over and over again in the Race for Oceans activities since 2019, it's not an option anymore to leave the trash or the plastic out there for the next generations to solve. So we want to find a solution now that can handle this. One of the things that we have seen over and over again, this is plastic pellets. This is the raw material to create any given plastic product. And this is the third largest source to microplastic pollution in the oceans. It ends up in nature either when they are produced, the plastic pellets, or when you want to produce the plastic products, or when you do the whole transportation phase of the plastic pellets. So that's the way they enter into nature, and it has been going on for the last 65 years. So we've asked the participants in the Race for Oceans community since 2019, and 98% of them, they don't know what plastic pellets are and why they end up in nature. So this is a huge problem. As you can see, the EU Commission, they stated that between 52 and up to 184,000 tons of plastic pellets enter the environment every year in EU alone. Regulation is on its way, but we cannot wait for that because we need to start to clean this up. The solution that we look into is create the synergy between AI and drones and robots to clean up. And we want this technology solution because we want to put biodiversity at first, instead of having a mechanical solution where you go in and you remove a whole layer, and then you disrupt the biodiversity by doing a mechanical solution. So we'll see how we can utilize the technology and the synergy. Where we are now is here. To create AI model for drone. And the next phases that we look into is how we can do the whole community engagement with develop a platform for drone pilots. So drone pilots all over the world, they can tap into this platform and upload video. And then another platform for all organizations working with cleanup activities all over the world, and how they can engage the participants in using their mobile phones to collect the data with the video and upload it again on a platform. Then we will have the newest data from all over the world to train the AI models in the future. So since August 2022, we have collected the data, a lot of data by hand, and we have more than plus 100,000 pictures of plastic pellets in the natural environment along the coastline. We also integrated technologies in our activities along the coastline, but all of this data, Troels will come into that later. We have used that to create the AI model for the future.
Yeah, my name is Troels. I'm the technical aspect of Race for Oceans. I actually have a background in computer vision and technology from the Institute Thomas Moslund is on. So like Signe said, we need to collect all the plastic pellets. It's not an option. We need to do that on the beaches first, later on maybe other places. But before we can collect them, we need to know where they are. So instead of just, what Signe said, we've walked around alongside the west coast, capturing images of plastic pellets in the natural environment. but we want to do that in a way that we can do it faster, and we turned our head to drones. So this is actually up from Grønhøj Strand, up between Blokhus and Løkken, where we have a drone pilot and a dog. And then we have a big lens and a camera on that drone. So what we did was that we flew the drone at different heights in an area of the beach in order to see what can we actually see, which is it possible to see the plastic pellets, and it was. We flew in different heights, 5, 10, I think up to 25 meters, and with the lens that we had that day, it's a company called Phase One that we worked together with. We were able to get really good images from 5 meters in heights, where we can actually detect the plastic pellets. What we want to do, what is possible to do in the future if we have a bigger lens, is that you can actually use drones with wings instead. Imagine flying over that beach, an area miles and miles ahead, up and down the beach, and then get a heat map of the distribution of plastic pellets. Then it's easy to see where are the hot spots for collecting the plastic pellets. What is the distribution of the pollution of plastic pellets actually, because they are not all lying around scattered across the beach evenly. There are hotspots, and we think that we can probably collect 90% of the plastic pellets on the beaches by just going over 10% of the beach. But we need that mapping in order to be able to determine that. We did was that 2 years ago, I think? Last year, time flies. We did a cooperation with the Trifork, where we actually developed a rover, that's the one in the image, that could collect the plastic pellets on the beach. It was a prototype, so even though we're on the beach, we got it working in the laboratory, so it's not a commercial product yet, but a rover where we actually mounted a camera, and we had a 3-axis, I don't remember the name, gantry robot system for actually collecting the plastic pellets. So this is just to show that what we're doing in terms of creating a map of the plastic pellets on the beaches can be used later on with drones like this or similar to tell these are the hotspots, go here, go pick that up. So the images that we collect with the drone are not for the actual picking of the pellets. It's just for creating the heat maps, and then we could use drones with their own cameras to actually pick up pellets on the beaches. So where are we now? Like Signe said, the phase we're in right now, we are investigating what models to use. How do we actually segment the pellets in the images? How do we track them? How do we create the heat maps? And this is just a high-level infrastructure of what it is we want to create and what it is that we need for the next phase. As on a more technical level, it should all be cloud-based. So we have an infrastructure track. We want this to be available in the cloud, so you can actually just log onto a web page. There's a front-end track, because what we want to do is that we have the drone that can actually collect the images. There are a lot of drone pilots all around the world. So this is all about creating a community where people can actually upload images from beaches all around the world. So we can actually have a community that contributes to mapping the distribution of pellets on beaches around the world, so we can get an overview of how bad is it, or how bad is it. There's an AI development track, which is the one we're going to focus on first, because what we're going to do next is actually create the model that can actually detect these pellets from the drone. So that means not necessarily detecting the individual pellets, but detecting the clusters of pellets on the beaches. And then, of course, later on, putting it all together. Perfect, because I think that was what I had.
Yeah. Yeah, so we look into a different kind of use case. So it's not just on the beach that we want to collect the plastic pellets. We want to collect all trash in the future, but we are starting with plastic pellets because it's pretty easy to design the AI models for a constructed product. But we also see these kind of use case in the future, and especially the last one is very new, but it is a mapping software that actually has a dual use potential for when you have a war zone that has been stabilized and you want to rebuild this area so people can move back into the country again. Yeah, that was us, and this is actually the first pitch that we do together, so bear with us. Yeah, so feel free to connect and questions. Yeah,
thank you very much. And we have time for one question from the audience. Anyone has something you would like to ask?
Yeah.
I can ask. Very interesting. Beaches are quite dynamic, aren't they? There's moving sand and so forth. So if you go and track an area and upload it to your interface or your web, what's not to say that there's not a nice walking storm past and moves everything and redistributes things. So yeah. That's kind of the first question. The next one would be, if you look at the sediments along the west coast, as an example, if you go down to the Sletterstrand, you've got a very rocky environment as opposed to up here in Grønhøj. So have you given any thought of how you can actually take that into consideration? Because some of these pellets, they're quite the same size as sediment sometimes.
Yeah. So they are from 2 to 6 millimeters in diameter and fabric made, so to speak. I live in Løkken, and I lived there for the last 5 years, and I've been along the west coast of Denmark for around 5 times, so I know the whole west coast. So of course the environment for us is really interesting, and that's why we also want as much data from all over the world when we create the AI models.
So concerning the storms, because it does change, and then after a storm you'll have these clusters of plastic pellets because the sand is disrupted and on the surface and stuff is coming in from the sea, and that just talks into the fact that we need this because we need to continue. We can't say that now we've mapped this beach, done. I mean, this is going to be something that needs to be done continuously. And if we have the drone that does the mapping, and we have the rovers, a cluster of rovers that does the cleanup, they need to work together at the same time, of course. The first step is just we want to get a distribution map, so the people that needs to pay for getting this cleaned up can actually get an overview of how bad is it. But it is a dynamic problem, and it will change, and then you clean that up. There's a storm. You go clean it up again. It continues.
It could be there's actual certain times of the year that are actually more favorable to do the cleanup.
Yeah.
You have those high water marks and high tides and storms that push a lot of the pellets up.
Yeah, so the whole weather data is also something that we will look into in the next phases. Yeah.
Very cool.
Yeah. So there was 65 years where we know that the plastic pellets has been, put out in nature. So perhaps we're also going to use the next 65 years to remove it. Yeah.
Thank you very much.